Hello and welcome to part 3 and hopefully the final part of this study guide video. Although constructive response may be its own video, we'll see. One can only hope it doesn't take that long. All right, so number 20 is where we left off. Select the correct solution type for each linear system shown, circle your answer, and explain how you know in the box provided. So, if we look at this first one, this is a pair of parallel lines. They do not intersect, therefore they have no solution. So they have no point of intersection. Okay, this one we have a point of intersection is one solution. So the lines intersect at one point. And then if we look at this, it looks like one line, but it is in fact two coinciding lines. So this is two lines on top of each other, or I guess two lines that coincide. Coincide. Cannot spell this for the life of me. So it's two lines that coincide. They lay on top of each other. They share all points. Woo! All right, there's 20. That's it. So we have no solution, one solution, infinitely many solutions. 21. Which ordered pair is a solution to the system of inequalities? So if you look, we have this inequality, and it's a greater than, so it's shaded above. We have this inequality, it's a greater than, it's shaded above. This area right in here is double shaded. It's where both of these inequalities, the shading overlaps. So which of these points is in this overlapping area? -3, 0 is over here, so not this one. 6, 1 would be, I'm sorry, that's 6, -1. So that would be here. No. 2, 4. 2, 4. Yes. 0, -4 is not a solution at all, so no. So this is in the double shaded area. Or double shaded region. Let's be fancy and use like smart people words. Okay, number 22. Consider the system of linear inequalities which ordered pair is a solution. Okay, so only way to solve this is to graph. And again, why not use Desmos? So we can, especially considering, I'm going to scooch this over so that when I click on this, it doesn't go away. Considering these are not in y or slope-intercept form, we're going to type it in. This is an ugly one, so we're just going to do the best we can. So 4x plus 3y is greater than -6. Okay? And then I'm going to just come over here and graph it just to be consistent. So we have 0, -2 as my y-intercept, 1.5, 0 as my x-intercept. Do I have another point that would be easy to graph? -3, 2. Okay, I'm going to take my ruler. Maybe it's stuck under my keyboard. Let's see, and that should be an open line. And we're shading above, so I'm going to shade this area. I'm not going to do... Okay. So one thing I can do is anything that's not in this area, I can go ahead and eliminate. So -4, +2. Here, let me do this. Negative 4, positive 2 is right there. That's not going to work. Negative 2, positive 1, I believe, is on the line. I don't think that's going to work, but we'll see. Positive 2, negative 2. Okay, that could work. And 0, 4 could work. Okay, so we've got C and D. Let's put in the other equation, which is right here, x minus 3y is less than or equal to negative 9. Okay, I'm going to come back and graph over here. Let's see, that looks like 0, 3, negative 9, 0, so 0, 3, negative 9, 0. I'm going to, and that's a solid line, and shade it above. I'm going to shade that in yellow. Okay, so since I've got a blue and a yellow, anything that's in green would be a solution, figuratively. So anything in this area would be a solution. So let's see, we already eliminated these two. 2, negative 2. 2, negative 2 is down here. 0, 4 is up here. So 0, 4 should be our solution. I'm going to double check on the fancy graph. We have negative 4. Ooh. Let's see. Come over here. All right. Negative 4, 2. Negative 4, 2 is right here. So that would be a solution to the green, but not the blue. Negative 2, 1 would be a solution to blue, not the green. Negative 2, negative 2. I'm sorry, 2, negative 2 would be here. It's a solution to the blue, not the green. And 0, 4 is up here in the double shaded area. So that would be our solution. All right, so our answer is D. Okay, let's flip this. Oh, wait, no, I'm sorry. I didn't do these double-sided, I did these one-sided. All right, last two problems before the constructive response. Okay, the graph shows the predicted growth of an American elm tree that is planted under ideal conditions when it is 6 feet tall. What are the coordinates of point A labeled on the graph, and what information does it provide? So we plant a tree. It's 6 foot tall when we plant it. This is the time. This is the height. So if I look, after 2.5 years, so that's my x value, 2.5. After 2.5 years, that is a very difficult point to see. I'm going to assume that that is actually on this point right here. So that would be at 14. So after, and use these to help you. So after 2.5 years, the tree is, so let's look at my height, 14 feet tall. Okay. All right. That's it. We're just interpreting the point. We need to get really good at that because that's the whole point of graphs. It's not to just be annoying. It's to actually have some help and to actually use it in the real world and to represent things so that we can read charts and whatnot. Okay. The graph provided represents maximum and minimum projected business growth of a new salon opening in town. The top line is the maximum number of clients or that they're projected to have, and the bottom line is the minimum number of clients. So these are some business projections. This is the most I could gain. This is the least number I could gain. What is the equation of the line that represents maximum business growth? So if we look, these both start at 0.50. We're going to start with a y equals, and we're going to get our slope. So we're going to find an easy, let's look at this. This is 5,000. over the course of 8 years. So we went from 0 to 8 on our x, and 50 to 5,000. So this is our slope, and then our y-intercept is 50. So we're going to just go ahead and subtract 5,000 minus 50 is 4,900 over the course of 8 years. So divided by 8 is, did I do that right? Yes. Okay. Is that 8 years? Did I do that right? No, I'm so sorry. I somehow got off. That is over the course of 9 years. So 4,950 divided by 9. That makes more sense. 550. Okay. So we have y equals 550x plus 50. All right. From what does the coefficient of x represent? Well, let's look at this. This is the number of years. This is the number of clients. So these are the amount of clients earned per year. Or the number of new clients each year. Okay, what does the constant represent? So the constant would be this plus 50. That is our y-intercept. That's how many clients we started with. Boom. All right. I'm going to pause this video because I'm realizing it is 3 o'clock and I have to pick my kid up, so I will be back shortly. All right, so I am back. I have my kiddo with me this time. Can you say hi, Jim?
Hi.
All right, can you go back to erasing my board? Okay. All right, so we're going to work on the constructor response portion of the unit test, or Unit 3 study guide. So at the bottom, I want you to notice you have a student checklist. I want you to check everything that you do. I just realized that I don't have the right number of elements on there, but that's okay. 1, 2, 3, 4, 5. I think we have 5. Are you okay, baby? Don't stand on that trash can. Use this chair. Okay, so should have 5 elements. All right, so first things first, annotate the problem. We want to, Jim, baby, be quiet. We want to make sure that we highlight everything we're supposed to do. So even before I read like the context of the problem, let's go to each part and see where my points are coming from. So part A, write an equation. And we want that equation to determine the number of bags of plain chips. So we're not solving it, we're just writing the equation. Part B, we're going to solve the equation. And then we're going to use that info to find the number of bags of each flavor chip. Okay? All right. And then part C, we have some information. We want to write a system of equations to model this. We want to use our system to determine the number of compartments with 3 passengers and the number of compartments with 4 passengers, and we need to show our work. So that gives us 1, 2, 3, 4, 5, 6 elements. I was wrong. It's not 5, it's 6. So I'm going to put this here. 6 elements, 6 elements. Okay, so let's go to part A. We need to write an equation. So we are asked, we have that a train offers bags of chips as snacks to passengers. They offer plain, sour cream and onion, and barbecue flavored. They're in bags of chips. In bags of plain chips. The number of sour cream and onion is 20 less than triple the bags of plain. And then the number of barbecue chips are 3 more than double the sour cream and onion. Okay, so we want to write an equation. So we have, basically what we're doing is we are adding the plain, the sour cream and onion, and the barbecue together. I have left out a very important detail. Not what's in black, but everything else. Thank you. I just realized something very important. We don't have the number of chips. I have it written down here. We're going to add it to the study guide before we print it. There are 413 bags total. Okay, so all of our chips together, if we add them up, we get 413 bags. So our plain chips, there are N bags of plain chips. Okay, so there's our plain chips. I'm going to highlight that or underline it in yellow. Sour cream and onion, we have 20 less than triple the plain chips. So triple means to multiply by 3. So we're going to take our plain chips and multiply it by 3, and then we want 20 less than that, so we're going to subtract 20. Alright, so there's our sour cream and onion, that's in blue. And then our barbecue chips are 3 more than double the sour cream and onion. So I'm going to take the sour cream and onion, which is this big thing, and multiply it by 2. And then I'm going to add 3 to that because it's 3 more than double. And our total is 413. Do that in orange. Alright, so here's our plain chips, our sour cream and onion, and our barbecue. Now I want to clean this up to make this a pretty equation. We're going to distribute the 2. And this becomes 6n minus 40. And we still have our plus 3. We still have our n plus 3n minus 20. And then we're going to combine like terms. N and 3n is 4n. Plus 6n is 10n. Negative 20 and negative 40 is negative 60. Negative 60 plus 3 is negative 57. And it still totaled to 413. Okay, so this should be our total number of chips. All right, we wrote our equation. We have addressed this element. Okay. And this should make sense. So, yes. All right. Part B. Solve the equation and use the info to find the number of bags for each chip. So the first thing we want to do is solve the equation. So we have 10n minus 57 equals 413. We're going to add 57 to each side. And we have 10n equals, if we add this together, we get 470. We're going to divide each side by 10, and n equals 47. All right, so what does that mean? Well, n is the number of bags of plain chips. So there are 47 bags of plain. Now I need to know the bags of sour cream and onion. Well, sour cream and onion is 3n minus 20. So we're going to do 3 times 47 minus 20. And we'll come over here and do this. So 3 times 47 is 141 minus 20 is 121. So we have 121 bags of sour cream and onion. And then our last one, our barbecue, we are going to do 2 times, so it's double the sour cream and onion plus 3. So we already have the sour cream and onion as 121. We're going to multiply that by 2. We're going to add 3. And that gives us 245. And I'm just going to rewrite this down here. We doubled the 121 and then added 3. And then how could I double check this? Well, we have a total of 413 bags. So 245 plus 121 plus 47 equals 413. So that is a reasonable answer. That's a good way to check to see if we're right. Okay, and I am going to box my total answer just so I've taken care of that. Okay, so out of our 6 elements, we have written our equation. We've solved it. We've used the information. And we've gotten all of our flavors of chips. So now we're ready to move on to part C. So, I'm going to go ahead and check this off. We've done that. Restated the question in my response. So, on the writing the equation, it's kind of hard to restate the question, but we did do that. Here we have 47 bags of plain, 121 bags of sour cream, and 245 bags of barbecue. And we'll make sure that we restate the question here. Okay, so we want to write a system of equations that can model this situation. So, a train can sit up to 336 passengers. There are 84 compartments that will comfortably seat 4 passengers each. Alright, so on this particular train ride, there are 292 passengers. There are exactly 3 passengers in X compartments, exactly 4 passengers in Y compartments, and 3 compartments are completely empty. So let's look at this. We have 84 compartments total. We have X, this is the number of compartments with 3 people. This is the number of compartments with 4 people. And then we have 3 that are empty. So we have 3 more compartments. This should total up to 84 because there's 84 total compartments. All right. Then we want to talk about our passengers. We have 3 passengers per compartment X, and then we have 4 passengers per compartment Y, and we should have a total of 292 passengers. So you notice this 336 they gave us, that was unnecessary. We didn't really need to know that. We did need the 84. It is nice to know that they seat 4 passengers each. We did need to know that 3 were completely empty. 3 in X, 4 in Y, and a total of 294. So we have our system. We have written our system. Okay, now we want to determine the compartments with 3 passengers and the compartments with Y passengers. So we need to solve our system. Lucky for you, you do have Desmos. You can do this on Desmos. What I think I'm going to do is let's clean this up and we can use elimination. So we have X plus Y plus 3 equals 84. I'm going to subtract my 3. And then we have X plus Y equals 81 and 3X plus 4Y equals 292. Let's take this and multiply by negative 3. So, negative 3 times X is negative 3X. Negative 3 times Y is negative 3Y. And negative 3 times 81 is negative 243. I just did that in my calculator, but it's off to the side so you can't see it. So now what happens is since I multiplied by negative 3, I can now eliminate the X variable. That's gone. 4 minus 3 is 1Y, so I just have my Y value, and 292 minus 243 is 49. So what this tells us is that there are 49 compartments for Y, and that's how many have 4 passengers. So 49 compartments have 4 passengers. Now I need to know how many have 3, so I need to figure out my X value. I'm going to come back to this equation. X plus, instead of Y, I'm going to put in 49 plus 3 equals 84. 49 plus 3 is 52, so X plus 52 equals 84. We're going to subtract 52, and 84 minus 52 is 32. All right, So I have the X is 32, Y is 49. Well, what does that mean? We want to determine how many compartments have 3 passengers and how many have 4. So 32 compartments, whoop, I'm running out of room, have 3 passengers, because that was X, and 49 compartments have 4 passengers. Okay, I'm going to box this off so that you can kind of read that easily. We restated the question here. So we used our system and we did show our work. So we have addressed each element and we have, we checked to see that these made sense. Let's try this one though. We have 32 compartments plus 49 compartments. That gives us 81 compartments, which is what we needed. If we add the 3 empty compartments, that gets us to 84. Perfect. All right, check this 292. 3 times 32 is 96. 4 times 49 is 196. And 3 times 32 we said was 96. Add that to the 196 and that gives us 292, which is what we were looking for. All right, so we checked that these made sense. Our checklist is complete. We've annotated our problem. We've restated the question. We've clearly marked our answers. This would be a 20 out of 20 page. All right, I hope this was helpful. If you have any questions, please let us know, and I hope you guys have an excellent day. Take care.